Hello and welcome back to my workbench. It is time once again to fix something. And today on the workbench I have another dead PS5. And I think this is a totally dead one. We'll find out here shortly. But yeah, I think it's obviously it's a fat. I haven't looked to see what version it is. And I would love to plug the power cord into the back of it and try to turn it on. However, when I was taking it out of the box, I did notice something. If I could show you back here. Is that going to focus? Yeah, that's liquid metal. So I'm a little concerned about just turning it on. So I think we will take it apart and see how much of that liquid metal is scattered about and go from there. All right. All right. Let's look at the other side. How bad is it? Well, could be worse. Oh, it's escaped right there. You can see it up under the edge of this sticky heat transfer stuff they like to use. Plus we have a nice dry spot, but it has definitely leaked right there at the corner, and hopefully it did not go too far. But we saw it on the outside of the case, so yeah. So maybe not too much cleanup, just a little. It's a good place to start anyway. Okay, could have been a lot worse. Let's see if we can clean some of this up before it goes any further. You can see it's definitely crossed a couple of pads right there for the RAM. Can we get it out from under there? So is this a no power, or was it a beep on off because of this liquid metal? We have not applied power to it yet. I'm going to give this board 12 volts here in a second. Is that flux? Also, I thought I saw, does it look like somebody has soldered to this coil? It does a little. So that's concerning. They're trying to inject voltage there. I mean, all these are CPU rails, so they're all going to be low impedance. And whatever that is. Okay. And that looks like flux. Or is that just alcohol? Maybe it's just alcohol where I've been cleaning. All right, let's give this board 12 volts and let's just see what kind of initialization we get. Well, I think I'm ready to give this board 12 volts. As long as my polarity is correct. Let's just see what kind of initialization we get. We're not going to try to turn it on or anything. All right, that looks good. Yeah. Which makes me suspicious this was not a no power, but rather a beep on off. Okay. All right, before we try to turn this thing on, I think I want to look around with the meter and see if I find any shorts because of this liquid metal on any of the APU rails and stuff. So let me get set up for that, and we'll see if we can find anything suspicious. Let's take a quick look around the board on some of these common rails where liquid metal might fall, like this would be the 6-phase for the APU, 0.27. That's probably about right. And this should be, what is this, like 6 ohms or something? 7.5. That looks fine. Right here beside the APU, these little vias, 289. One of these is a 0.75, and the other one's 1.8, I believe. And that looks good. No shorts there. What about, now these will be kind of low impedance, like a few ohms. 24 ohms, that's fine. 3.25, that's fine. It looked like somebody's tried to inject there on that 3.25, but that's totally fine. I think my understanding is this is basically the power rails for the CPU side of it, and these are the power rails for the GPU side of it, you know what I'm saying, which is obviously higher power. That's why it's got all this elaborate multiple rails to it, multiple phases to develop the many, many amps of current going into that thing. What about the RAM? Did I check the 1.35? I think that's probably fine, 50-something ohms. I didn't notice what kind of RAM this was. Samsung? It is Samsung. I'm going to guess our south bridge is fine. That initialization looked textbook, looked beautiful. So our 5 volts isn't shorted. So is this just a simple beep on off because of liquid metal? Let me check on, like it was in this corner right here. So if I check on these little pads, these are unpopulated pads where that liquid metal is laying across. One side I'm sure is ground. .53 ohms. The other side must be ground. If I can make the contact. It's a rather small contact. Yeah. So our 1.35 was shorted to ground. It would have had to have been because that liquid metal was splashed right across these unpopulated pads for capacitors. This thing might turn on. Is it really that simple? All right, it's time to find out. I'll slip it back in the chassis. I need to clean up the liquid metal on that heatsink a little because it's kind of, it's kind of wandered away itself here. So I need to straighten that up and clean this up a little. But I don't see it all over the place. Okay, get that out of the way. Let's give it some power. And AC is on. And the power supply did not start. I did not see a dip on my meter for the isolation transformer. I think the power supply is dead. What are the chances? Yeah. Rather dead. Not shorted, just dead. Okay. This is a EDM10 board. You know, this is the original PS5, so this will just take a 400 DR, which I have in abundance. Okay, let me take this other side panel off. Oh, look at that. Let's just go ahead and get that before it goes any further. Is there liquid metal in the power supply? Where was that glob I saw earlier? Right there. Okay. Now, as I was saying, drop this power supply out. Let's see. Don't want to rip my ribbon for the LEDs. Oh, I don't have it. Wait a minute. Why is the heatsink staying there when I pick this up? Are the screws out of the heatsink? Oh boy. Yes, they are. And there's the rest of our liquid metal. Scattered in and about. So yeah, somebody's been deep in here. And yet they didn't clean up anything. There's definitely liquid metal on the exterior case here. See if I can push that back up there. Where else did it go? Well, it's all over this, you know, steel case here, which it will attack this metal at some point. Yeah, it's already started to eat the coating off of it. That's why it looks a dull gray there. If it shows up too well. It has started eating the coating off of it. So it's been there a little while. Oh, and that's popped off. It's part of our containment for our liquid metal. Need to glue that back down. All right, at some point my capture hard drive filled up and the recording cut off, so I'm not sure what I'm going to have and what I won't. I'll find that out when I'm editing. But I've just been cleaning the liquid metal like crazy. It was everywhere. I have reattached the heatsink to this back plate and cleaned up the liquid metal. You can see where it's eating the finish off right there, where it's so shiny. So I did find a resistor. Source mount resistor I've got laying over here. I hope that didn't fall off this board, which sometimes happens when liquid metal gets places. It will dissolve the solder. It attacks the joints and just components fall off. So I'm not sure if it's a tiny resistor laying over on the workbench. If that's from the previous thing I worked on this one, we'll probably find out. I still got liquid metal scattered everywhere on my workbench here, but I would like to slip this into the chassis with a working supply. This is the supply that was in it. It is dead, so I'm going to put it to the side for right now and grab another working supply for testing. Just try to clean up some of this liquid metal before I get it all over the case and everything. We will slip this in here. Okay. Where did I put that working supply? Right over here. Okay, I've got this stuff all over my hands, on my fingers. Got to make sure I wash my hands quite well, because that liquid metal is some nasty stuff. Trying to get these cables out of the way. They always hang when I go to put this assembly back in there. It kind of gets in the way. Okay. Get the ribbon cable out of the way. Okay, I think that's down. So, can we get a white light? Let me hook these ribbon cables. All right, there's our LED ribbon cable hooked back up. Not really worried about Wi-Fi and Bluetooth cables right now. Maybe I'll hook the fan up just for the positive feedback it gives. Let's see. Give it some power. I did see that supply start up. What's she gonna do? Yeah. Yes. White light already. That's awful quick. It's got to be doing a storage check right now. So I'll let it finish that. Okay. So maybe that resistor wasn't from this board. I just need to look around, maybe have a look around that area where of the RAM, where the liquid metal, where I saw it sitting there. Because if there was a resistor, I think all those pads were unpopulated, but I think they were all unpopulated. Back to a blue light, so she's done doing a storage check and she's starting over. And we should come up to a white light and 3 beeps. There it is. All right. This is encouraging. All right, let me see if I can shut it down properly. And I may have a quick look around with the microscope, see if I can see where that resistor may have gone. But maybe it's from the previous, who knows. do a proper shutdown on it. Let's not try to corrupt the software. And all right, I'll move it over to where my monitor is, and we'll see if we can get a picture out of this thing. All right, here we are set up over at the testing bench, kind of my testing and burn-in bench. Let's see if we can get a picture on this thing. Hey, we got a picture. All right. Excellent. So, does that mean all we have to do is fix this power supply, which I have laid down somewhere? Yeah, we're back up. All right. What do I do with that power supply? I think it's over here. Okay. Let's crack this open and see what's wrong with this thing. Okay, let's take a look at this power supply. I am wondering if this was the only problem, that this system had. Like, when did the liquid metal leak happen? Did it happen in shipment to me and just had dead supply? But then again, the console had obviously been open. So why didn't they just replace the supply? Why didn't they at least try another supply? I don't understand that part. Because I'm wondering if this was another eBay special where they took a dead power supply and a board that would not start up because of leaked liquid metal and threw them together in a box and sold it to some poor sucker like me. I really don't know. I don't know what point that liquid metal leaked out. Finally. So, I have had this plugged in, so I do need to discharge it. I'm not seeing any liquid metal inside the case here. So, it's probably not why it died then. Also, no roach signs, no nastiness from roaches. Capacitors aren't swollen. Let's see what's shorted, what's not. What could possibly be wrong? Fuse. Fuse is good. How about this fusible resistor right down in here? R9. Can I get to it from the top? It's good. So if that fusible resistor is good, that most likely means these MOSFETs over here are going to be fine. Yeah, because they would blow immediately. The fuse was good. So what's dead? Just the controller IC, the DAP053. Let's just take a look and see. Shouldn't take too long to figure it out. Pin 1. Pin 1 is shorted. Probably several others shorted also. 2, 3, 4 is ground. That's fine. 5, 6, 7, 8, 9, 10, 11, 12 is no connection. 13, 14, 15, 16. So is pin 1 shorted, or is there something on that pin 1 point that is shorted in parallel? Let's take a look at the schematic and see what pin 1 does. Okay, here is my schematic for the 420, I'm sorry, the ADP 400DR, not the 420. Let's take a look at pin 1 of this controller, the DAP053. What does it connect to? Here it is right here, disappearing off to the left. Diode isolating the temperature sensor, but it goes back to the input circuit right here. And you can see right away we've got a 10 meg resistor here, 10 meg resistor over here. So our short is not likely to be over this way because there's 10 meg of isolation. Here, not likely either, because even if this diode were to short, you still got 7.15K here and the resistance of this negative temperature coefficient resistor here. So yeah, I'm afraid it's got to be the chip. Like if this shorted, even if, unless this diode and this capacitor somehow shorted, which is not very likely. So yeah, I want to say that this IC took a surge of some kind, because if you look where this comes from on pin 1, it's sensing the input AC. It's sensing both lines of the AC line, here and here. With some isolation, there's resistors, 10 meg ohm, 10 meg ohm, but still a nice healthy spike does seem to come in sometimes, and that's the end of the line for the chip. So let's swap out this DAP053, and I bet that gets it going. All right, well, with our DAP053 changed out right over there, let's see if this thing will do anything. I am monitoring the PFC boost voltage to make sure that doesn't run away or anything. Got my load on back here. It's set for 5 amps. Turn it on. Let's give it some AC voltage. I'm turned all the way down here. So let me ease this up. The voltage is coming up. Our PFC voltage. Let's see if our 12 volts comes up. No, it should have already started by now. Should have already started. Nope, we're not running. So what else did we get? What else did we damage? I never even saw it try to run, which is strange. I don't think it's not drawing any current. I'm going to switch this meter to current and bring it up. No, it never draws any current. The capacitors are charged, but I never see it even bump. It does not try to start. Okay. All right. We still have further problems. So not going to be that easy as just swapping out that DAP053, which I'm sure is bad. It had a shorted input. I need to discharge this to Make it safe to touch. Get that meter out of the way. Get my discharge tool. Now the PFC never tried to start. That's unusual. Okay, we are discharged completely. So what gives here? Do we have, I don't think we had any other, questionable pins on this chip. This is our new chip. Pin 1 is fine now. 2, 3, 4 is ground, that's fine. 5, 6, 7, 8, 9. That reads low, but if I check the next pin, it'll be normal. Make sure I've got this 1, 2, 3, 4, 5, 6, 7, 8. 9 is reading low, but if I just check pin 10 and go back to 9, there you go. So it latches something up inside the chip. Kind of makes you think it's bad, but it's not. So 9, 10, 11, 12, no connection on 12, 13, 14, 15, 16, okay, that looks reasonable. Let's look at these, what am I trying to say? Opto-isolators, couldn't think of the name right then. IC51. No reading on pin 1, that's fine. 0.6 on pin 2, that sounds fine. This is IC53, ground, yeah, that's normal. That looks normal. And IC52. That looks totally normal. All right, diode readings looked pretty good. However, we're still not running. Something else that I've seen, though, that we need to check is pin 2 of this chip. Pin 2 is where the feedback voltage comes in for the power factor correction. It's divided down, and we'll look at it on the schematic, but what you should measure on pin 2 is about 100K, 96K, 100K, something like that. So if I go negative terminal on the negative large, the negative of that large bulk capacitor down there, and go to pin 2 of this DAP053, and don't slip off 2K. All right, that's very low. And that pin 2 being pulled low, being pulled to ground, is a signal to this chip to shut down. So the chip is not running because it's being told to shut down. That's just one of its shutdown mechanisms, is a low signal on pin 2 if you pull it to ground, if you disable that feedback signal. And that's done by a MOSFET. Let's just look at the schematic right quick like. Where was that? Here we are. Pin 2. You see right here? And you'll see that there is, right here, dividers, 7.5 meg, 7.5 meg, 750K ohms, coming down through here, a zener, a 100K ohm to ground. On some of these boards, different models, that's like a 95K or something, but same principle. So roughly you should measure 100K on pin 2. When you, with everything in circuit, normal, everything discharged, you should measure to ground about 100K ohms on pin 2. However, down here, this MOSFET will short and pull it to ground all the time. See, that's how it, that's where the signal comes from the other side, from the cold side over here. That's how it shuts the system down with this opto-isolator. It pulls that point The opto oscillator drives the gate of the MOSFET, and the MOSFET then pulls that low and shuts it down. So I'm going to be pretty sure Q34 is going to be broken down. It's not hard short. It's like 2K ohms, but it has broken down enough that that 2K ohm is more than enough. You know, with this divider chain up here being, 7F meg, 7F meg, 750K, with a 2K hung off the bottom of this down here, 2K short to ground, it's going to kill the feedback signal. So yeah, let's replace Q34 and see what happens. I could just lift it to test it, but I'm rather sure it's going to be bad. I've seen it before, so we're going to replace Q34, which is a 2N7002 BKT. It'll have 704 marked on the top of it, I do believe. Let's see if we can find it, if I can remember where it is. Let's see. Is it where I remember it being? Let's find out. I think it's down in here. Where did I lie? Is it there? Q34. I think that's going to be it right there. Then you see the 704 marking on top of it there? Get that in focus. So I do have some of those on hand. Let's get it changed out. All right, well, that little tiny MOSFET has been changed out, that 2N7002 KT, I think it is. Yeah, that's it. That's it sitting right there, which doesn't, it's tiny, tiny. I did confirm pin 2 now shows 100K ohms to ground, so that was that issue. Is that the only issue? I think we're ready. I've got this ready to watch the voltage as it comes up. Let's see if I start, turn that down, start easing it up. The voltage should start coming up, and it does. And we should start up, hopefully this time. There it goes. No, we shut down. We did try. The PFC started, but it shut down. Why? Why must you do this? It tries to run. Let's see if we get 12 volts out for a moment or something. Yeah, a little blip of something. Didn't approach 12 volts. We made it up to 360 or so volts on the PFC and the boost voltage. No, we still have another problem. We got to find it. So we are still shutting down. So I've taken another look. I think I found another bad component. Let me get this meter set up where you can see it in diode mode. Let's see. IC51 here is another opto oscillator right here. If we check on pin 1, that looks good. This is diode mode. Pin 2, 0.63. I think that's right. So that I think this is fine. But checking over here on the gate of Q32, 1.27. And let's take a look at the schematic right quick, like to check that. And here's where we're looking. But I don't have it on the notes here on the schematic what the diode reading should be. I've got it over here at the opto oscillator. I don't have it here on the on the gate. You can tell this is ground. You can tell this the drain is tied straight to this pin here, so you kind of have that reading. But I don't have the gate reading. So what I've done, again, let me go back and look at it again. This is the gate of Q32, 1.27. So I broke out a known good working board to look at here. So let's take a look at that same point right there. If we check that gate of Q32 there, we get open line, OL, overload, whatever you want to call it. It's open. You don't get a reading there. You still get the same, 6/10 there. This is ground. So I'm thinking this transistor has broken down. Q32, I think, has broken down in some way. The gate of it has anyway. So let's get that swapped out and see if that helps our low voltage issue. I'm hopeful. All right, after changing out yet another tiny MOSFET, I think we're at a point of testing. Third time's the charm? Is this the third time? I'm not sure. So let me get this set up where we can see it. Sit up there. All right, I'm meaning across the capacitors again. Output is connected. We have the load on. All right, let's start easing this up. Voltage is coming up. Is she going to shut? Oh, it didn't shut down before. I mean, it had low output. It was doing weird things. It was in like a partial shutdown. She should start running. There we go. Yep, that was it. That last MOSFET. Boost voltage is perfect at 395, 1199. Yeah, with a 5 amp load. I think we're in good shape. We're in good shape. All right. Well, all right, let's put this back together. And I'll be including a link in the description of this video for the to the link to the power to these schematics, these power supplies, the ones that I've created so far. I have shared those with the public in some forums, and I might as well share them here also with my viewers. So look for in the description for that link. But yeah, I think this one's back up in the land of the living. I'll put it all back together, and we'll give it a good test in the chassis of that PS5 sitting over there. Well, I have fully reassembled this PS5. Seemed to clean up pretty well. I've got a few more marks on it. I need to try to clean up on the outer shell, but yeah, our repaired power supply is in there. I think we got rid of all the liquid metal problems. It's installing a game right now off of the Blu-ray drive, so it's all good stuff. So anyway, I hope you liked that one. Thought it was somewhat interesting, educational, entertaining, any of the above. If you did, please give me a thumbs up. And I'll see you in that very next repair. Bye for now.